Okay, so this is the Sandwich 200 version 2 frame, which is being put together now. We've got the box halves, top core XY, and the Z assembly all done. This printer is triple lead screws onto revision 3 of the assembly for fitting these together. I just wanted to show you there's been a number of mistakes made in this, which I don't know if you can see there. I've had to cut that top out here because when it was in those hinges, it was catching on this part here. Now this was the original part I had for these tops of here, and you can see that they're hinged so that when you take this out, you basically pull that up, pull it forward, and with the hinges the idea was that it would do that, so that the plastic wouldn't break or bend the rod, and you can drop it out and that would stay in place quite happily there, and would actually rotate flat. So when the top goes down, so and the Z assembly and this part will be parallel. Unfortunately, what happened is that this part, when the top came down, would hit against there. Now I don't know if you can see, but when this part is in there, it's got to be just underneath here, and of course that's in the way and it won't hinge. By that one. So the next thing to do, next idea to try, was to have a sliding piece that slides in there. That's the original one. It's wider. You can see that's wider than this one. Unfortunately, if you notice, you've got a belt on here, 1, 2 and 3, so there's going to be pressure pulling that upwards, and of course I put this so that it would go in that way, not the other way, so that one had to go out. There we go. So finally we've settled for this one, where these come in from that side, on the back, and then there is a catch on there. Now let me come round here. When it is back a little bit like that, I've arranged it so that it will actually wobble, but when you put it there it's solid. But also the belt, which is springy, will pull in this direction, actually towards there, so that will be solid. It's actually this just a holder there. It's not critical. There's the bottom part that is critical that this is attached to. That is fixed with dowel bearings, with a grub screw on one side and a grub screw on the other to push them like that, so that the rod is clamped between the two, and then it won't move sideways either. That's been a bit of a discussion on RapRap forums. We've got to revisit that. And what I'm going to do is expand this out a little bit and put a collar on the rod in between the bearings with a grub screw on that, and then put a top on this housing with 2 screws to push that down, so that you can sandwich the bearings and the collar and the bearing between the thing, and then just tighten the 2 screws holding the top of the bearing holder and the bottom enough so that you're comfortable with the pressure, so it doesn't bind the bearings, but at the same time is enough to stop any kind of axial movement. Hey, I learnt a new word, axial travel. Awesome. Okay. Now there is under here there is a arrangement, there is a catch on here which fits into a thing here, a piece here, so that sits on there and it goes in from this direction, right? And here you have a wing nut and the bolt is on the other side. So this is on the top core, the blue bit is on the top core XY, and it fits downwards and then shuffles along going into the catches there. Now, very annoying. Can you see how long that piece is? There's only 2 bolts holding this on, this blue piece on, and it moves. I'm not happy. So I'm going to have to rethink that. Likewise, on these pieces, blue piece here, there is too much play in that to make me happy, and also it turns out that the machine tolerances on these little poo brain things, you can see the huge gap there, and it's because that is sitting on there. These are supposed to be 15mm things, but the machine tolerances on these are so inaccurate that as far as placement of the screw holes is concerned, that it's 1mm, almost 2mm down. So I'm going to have to take a bit off the bottom of this in order to allow that to thing, or just replace that bracket with an alternative. The box has proved to be very interesting, shall we say? Let me see if I can disassemble this without. I might have to put the camera down on you in a minute, in a second. Undo that one. Excuse me while I just put the camera down and. No, I don't want to scratch this table. There's a very close fitting things here. No, I won't do that. I'll do another video with this disassembled in a bit. Otherwise it'll scratch this table. Can you see how these are not complete lengths across here? Turns out that it's okay. The panel is, although it bends as a flat sheet, it obviously doesn't shear, and that strength is what's used. So these pieces are all attached strategically on in at least 2 locations. All these bars are attached, on extrusions are attached in at least 2 places, which ensures that they don't move about. Now, what I found previously was with the version 1, I had to put corner cubes in, because I just used these pieces, just attach them on, fine, no problem. I thought that'd be absolutely fine, and of course the bars rotated around this, which is a bit of a problem, especially for the long ones here. So what I've done is put in these pieces. Now these are from MakerBeam, and it is the only purpose for which these pieces are suited. Under no circumstances purchase these pieces for any purpose other than this one, and it's just to stop rotation, about axial rotation. Hey, cool word again. Stopping axial rotation is the only structural strength that this design of part provides. Full stop. There is no strength in it this way. There is no strength in it that way, because this will bend. But axial rotation about here is literally the only thing to provide strength that it provides, and that is the only reason why I'm using these parts. I bought 50 euros worth of these parts, and I'm really cross because they're completely useless. Ironically, many of these parts could actually be replaced by plastic. So for example, in this corner it would actually be better to replace all that lot with plastic. Likewise in this corner here, I could actually lose that bar altogether and just drop that against there, redesign this part so that I can put 2 screws, one there and one there, and that would fix that in place. Likewise that corner, the back one and the back one there. Now here, down here, again, this part is important to stop axial rotation. Good word. Axial rotation of this extrusion again, so that's why I've put these pieces in here, and I'm going to have to move these up to fit 2 more in here as well. The reason why is because if this hardboard starts rotating, which it will do because it's flexible about its plane, if that starts rotating, then the distance between here and here will vary, especially as you tighten these up. And that will cause these to drop out, and also when you start flexing the box, it will change. If that changes, it changes the whole frame, the dynamics of the frame, and that results in inaccuracy, especially at high speed with a lot of movement. So yeah, okay, so that's the bit that holds the front lead screws, and likewise on the other side. That holds the bottom extrusion of the Z assembly, so across there. Which is this bar here. There's a bearing hiding inside there, so the bed is on that and then folds up like that. So it is actually very rigid, and there is almost no space with the thing. It's very tight clearances on everything. Wiggle, wiggle. It's good stuff. Thank you very much.